SDA program, and we are from CSIR. We are going to present in the first half 3 presentations in the area of sustainability, energy, environment, cities and communities, which is connected to SDG 7, 11 and 13. We will have 3 presentations. We'll have a break after that for a few minutes, and then followed by that we will have 2 speakers in the area of industry and infrastructure, materials for global society, which is covering SDG 8, 9 and 12. Followed by that, we'll again have a question answer or discussion session, a few minutes, and then we have concluding session where we have a panel discussion. The panels are all ready to have a discussion on the topic that will be covered prior to the panel discussion, and then topic that is being covered earlier by Council of Scientific and Industrial Research. Just to give you a brief introduction about this council, which formed in 1942, and we are celebrating 81st year of our existence, having 37 labs all across India. We work in the area of aerospace, we work in the area of medicine, we work in area in the biological sciences, materials, we work in the agriculture. You take anything, everything that is possible for human development, we work, and our aim is to do a basic research or fundamental research to industrial R&D or industrial research, taking our technology to industry. And of course, we also look for societal impact. That's the main thing that we are looking at CSIR, and we have many other verticals related to societal impact. And of course, of late, we have started working in to bring up the culture of the startups, which is, of course, is doing quite well in India in last decade or so. With this brief introduction, I would now request the first speaker of this session on energy solution, Dr. Ashish Lele, Director of National Chemical Laboratory in Pune. They have been working in the area of hydrogens and fuel cells for a long time, and there you will just see that they will make a presentation which you will be finding out that we are already in the path to commercialization of hydrogen energy and fuel cells in India. Thank you, and taking forward, Dr. Ashish Lele, please.
Thank you, Dr. Shuddha. Very good morning to everybody attending in different geographies, and good afternoon to those attending from India and Asia. I would begin by sharing my screen. Just give me a minute. Please let me know if you can see my screen.
Yes, sir.
All right. Thank you very much. So I'm going to talk about CSIR's efforts in providing energy solutions. My name is Ashish Lele. I am the Energy and Energy Devices Team Director of CSIR and also the Director of CSIR National Chemical Laboratory. I'll begin by giving you a broad perspective of how India is evolving the energy transition. As a country, we are targeting a $5 trillion economy, but with low carbon GDP to double from the present 34 exajoules to about 75 exajoules. But as of today, we import a huge amount of carbon in the form of fossil energy as a source of energy. And in the process of converting that into energy, we emit a very large amount of greenhouse gases, making us the world's 3rd largest greenhouse gas emitter. The goal is to strive to achieve greater and greater what I call end-to-end clean energy security, which means from the materials required to produce energy all the way to the energy producing systems as well. in the background, we should keep in mind that India has significant amount of proven coal reserves and also a very large amount of other carbonaceous products such as agro residues and municipal solid waste, all of which are source of energy. India also has a large potential to create non-fossil clean energy, whether it is solar, wind, hydro, nuclear, and so on. And those numbers are provided over here. So in this background, it is therefore very clear that for India to manage this energy transitions in the coming decades, we must first and foremost improve energy efficiencies across the board so that we can reduce the carbon demand. We should move away from the conventional power stations to more of new technologies such as IGCC, which is also coupled with coal gasification and carbon capture and utilization. Clearly, India is moving significantly to clean power production through biomass, solar, wind, nuclear, and so on. We are also exploring, because of the variability of renewables, we are exploring many different energy solutions, whether it is in the form of batteries or green hydrogen and pumped hydro and so on. But the goal is going to be focused on technologies which offer greater prospects for end-to-end self-reliance, as I said earlier, and also ensure that the manufacturing sector is covered all the way end-to-end from energy generation, transmission, and the other parts of utilizing the energy sources, those value chains as well. So this is where India is heading to. And as CSIR, our R&D plans, our R&D programs in clean energy are completely aligned along this thought process. And what I'm going to do in the next few slides is to show you what are those 4 or 5 major programs, just give you the highlights of those programs and tell you a little bit about each one of them, but in very, very brief scenario. So the first is hydrogen energy. This is a very, very important component of India's clean energy vector. India is likely to become one of the global green hydrogen hub. It is the most suitable energy vector for deep decarbonization of what we call difficult to abate sectors such as refining, steel, cement, and so on. CSIR has created a very ambitious 100 crore program. We call it the Hydrogen Technology Program, where 19 CSIR laboratories are collaborating together, and we are working across all 3 major parts of the hydrogen value chain, whether it is production, storage, or utilization. We offer many differentitiated technologies. These are end-to-end technologies from components to systems. And in the video that you saw just now, we demonstrate to you India's first indigenously built bus, where all the components in the bus are indigenously developed. Beyond the components and system, we are also focusing on developing globally patented technologies for manufacturing the strategic materials that go in these energy devices, such as catalysts, membranes, bipolar plates, and so on and so forth. So we offer a bouquet of differentiated technologies for hydrogen energy. We have many successes so far. You saw the bus in this. We also have India's first hydrogen plasma reactor for green steel. We have indigenous PEM electrolyzers, backup power systems, and also a pressurized fluidized bed coal gasification pilot plant. In each of these programs, we have very strong industry collaborations. We are also developing vendors, particularly in the small and medium enterprises sector. And we are also putting in a lot of effort in developing skills and providing hands-on training across the entire part of the hydrogen value chains. We believe that hydrogen is meant to create a very, very large impact. And just one point there is, as an example, is even if 10% of India's trucking industry, which is a very large industry, starts running on hydrogen, the heavy-duty vehicle itself will reduce about 10 million tons of CO2 per annum. So that's the kind of potential we have. And there are many more such numbers that are available. The second important area that CSIR is looking at is sustainable aviation fuel. We have developed India's first SAF, and this is going to be very important because as a country, we will be mandated to use more clean fuels in the aviation industry post 2028 because we are members of CORSIA. Having SAF, making SAF in India also will attract a lot of transit traffic through the Indian airports where we can make SAF available. Our SAF technology is globally benchmarked, globally patented, it's differentiated. Therefore, our SAF is a 100% drop-in replacement for aviation turbine fuel. Our technology provides lower OPEX, lower CAPEX due to very smart technologies, cheap catalysts, and so on. We today have a 600 liters biojet fuel production in a lab scale plant in one of our labs in Dehradun. We have tested this biojet fuel in 10% to 25% blends in Indian Air Force flights, as well as in commercial SpiceJet flights. So the product is very well tested, and it is going through all the certifications required to introduce it for commercial introduction in the Indian as well as markets outside. The expected impact is also very significant. Just a 10% replacement of ATF with our biojet fuel can abate about 1.5 million tons of CO2 per annum. Our third important technology is dimethyl ether, again a very important energy vector. Today, we are importing all the LPG and the diesel in India, and DME is a certified substitute for both LPG and diesel. And therefore, Make in India DME will substantially reduce the imports of these two fuels. We also have in India a very significant scheme launched by our Honorable Prime Minister called the Ujjwala Yojana, which intends to replace firewood, which is a not so clean fuel, with clean fuels such as LPG. And if that LPG were then to be substituted by DME, that would mean a very significant reduction in import duties. Our DME is an easy retrofit into diesel engines and causes lower emissions. We again have a differentiated technology. We have globally benchmarked catalyst with 6 global patents filed. Our catalyst gives excellent conversion and selectivity. We have a small lab scale plant, which we have demonstrated for more than 5,000 hours. We have also demonstrated this DME fuel in blend with diesel or LPG in cooking stoves, in 2 or 3 wheelers, and so on. We are now in the process of scaling up in the lab for 100 liters per day, but even bigger of 2.5 tons per day of DME pilot plant. The designs are already ongoing, and we have a lot of expression of interest from many companies. As I said earlier, the impact is very significant. We can reduce 5 million tons of LPG imports, reduce very significant diesel imports by substitution, anywhere between 10 to 25% of these fuels with Make in India DME. The next technology that CSIR is heavily invested into is lithium battery technology. The importance of that is very, very clear. Our demand is for batteries is expected to go to a few hundreds of gigawatt hours. The imported cell technologies today may not be suitable, we think, for Indian conditions of different temperatures and different other climatic conditions. And also we feel that there could be threat of availability of the strategic materials that go in producing in batteries. And these are the key driving forces for developing this technology by CSIR. We have a wonderful technology. We have a semi-production level plant, which is at TRL 6. We have recently augmented this facility to produce 1,000 cells per day. We can produce batteries of advanced cell chemistries, especially differentiated NMC cathode processes. Our batteries are very tolerant for Indian conditions. We have built a very strong IP portfolio. We have done all the FTO analysis for the components, and therefore many industries are interested in partnering with us. We've recently signed a large deal with an Indian company to use these pilot plants and produce batteries at prototype scale in our plants. Therefore, our impact is to catalyze the gigawatt scale manufacturing of lithium-ion batteries, and this would then lead to other battery chemistries. And we are also very strongly building other chemistries which are non-lithium, such as the sodium battery technologies as well. The last technology that I want to talk about is bio-CNG. In India, we have a scheme of the government called the SATAT scheme, or the Sustainable Alternative Towards Affordable Transportation. And one of the important fuels in this is compressed biogas. And the scheme allows the production and sale of biogas by the oil and gas companies of India. This is clearly, bio-CNG is very important because it not only benefits farmers, it reduces the crude oil imports of the country. It helps to value add to the organic waste or the municipal solid waste that is generated. And more importantly, it also reduces the stubble burning problem that is big in India, especially in the winter months. Our two labs have created a very nice patented technology which has high rate of biomethanation technology in a what is called a AGR lift reactor. It also not only produces biogas but high quality biomanure. The biogas is then upgraded to pipeline level biomethane using a patented adsorption technology, and the biomethane that we produce fits all the BIS standards. So we have so far deployed 30 such commercial plants in India by licensing it to various companies. And the impact of this technology is very significant. Just to quote a number, 15 million tons of compressed biogas can replace almost 40% of the consumption of CNG, all of which is imported as of today. So these are very important technologies that we have developed, which are commercial scale technologies, and we are in most of them in very deeply in touch with industry and going forward with commercialization. There are other technologies which I will very briefly touch upon, which are at lower TRL levels. We have a bunch of technologies around smart buildings. These are buildings that are more energy efficient. They can reduce the intake of thermal energy coming through IR. They can use the light energy photovoltaics by using things like organic photovoltaics or dye-sensitized solar cells, and so on and so forth. So the idea is to try and develop buildings which are much more energy efficient, and because of energy efficiency, as I said earlier, that amounts to reduction in CO2 release from the HVAC systems that go into such buildings. Another project of rural importance is of biomethane from coal rejects, and this has been beautifully demonstrated in one of the districts where we have access to coal mines. By developing a microbial consortium that takes coal rejects and converts them into biomethane. What this technology offers is an alternate source of clean energy for rural India, and it's an appropriate technology suited for the needs in rural India. It produces highly efficient and environmentally acceptable clean fuels from coal. It prevents women from getting exposed to smoke and other particulate matter emissions from burning of coal. And therefore, it also gives you better health for women. It helps in skill development for women who can develop these reactors at their homes. And it reduces the burden on firewood collection and destruction, and therefore gives more time for rural women to do more cash generating activities. So these are other technologies which CSIR is heavily involved in, which is very suitable for rural India. There are a few other technologies which I will not spend more time on. The pictures here show you solar thermal dryers and solar salt works and so on, and they have been deployed at many rural locations, including the Lakshadweep Islands and so on. So with that, I thank you for your attention, and I'll be happy, of course, to take any questions towards the end of this session. Thank you very much.
Thank you, Dr. Ashish Lele, for a wonderful bouquet of work that has been done by different labs of CSIR. We'll go to the next presentation, and we'll come back in the Q&A session. The next presentation by Dr. Abhay Pashilkar, Director of CSIR National Aerospace Laboratory. He will be talking about air transportation and enabler for economic growth. Dr. Pashilkar, please.
Good day to all of you. I hope you can hear me, please.
Yes.
Thank you. So I will just share my presentation and then we can start. I hope you are able to see the presentation now.
Yes, sir.
Yes.
Thank you. So first of all, it's a privilege to be associated with the Science Summit at the UN General Assembly 2022. I am Abhay Pashilkar. I am the director currently at the CSIR National Aerospace Laboratories. So in that sense, we are one of the agencies which develop and design civil aircraft in this country. And air transportation is growing in this country. So I will speak a little bit about that and then move on to some of the future plans where we look forward to collaborations from both national and international players. So as you can see, India has been growing consistently at about little under 10% annually in terms of the traffic, domestic airline traffic. And here is a chart which shows you, with respect to the GDP per capita, the kind of demand for air transportation on the y-axis there. It's a logarithmic scale. And as you can see, India is still developing in terms of the demand for air transportation. And as a result, there is going to be a huge explosion in terms of the number of passengers. In fact, in the last decade, we have moved up from something like 10th largest domestic civil aviation market. Currently, we are now the 3rd largest. So in a sense, the growth in the domestic product is what is inherently driving aviation, and it's a synergistic relationship where aviation growth also then feeds into the GDP growth of the country. In terms of the policies that the government of India and as a country we are pursuing, we have the regional connectivity scheme, which essentially run by the Ministry of Civil Aviation, which promotes leasing and financing of new routes, which are then put up for auction. And as a result, more than 200 airports are now operational, and many routes have been opened out for private participation under the UDAN scheme. The next pillar of that policy is the leasing and financing through the International Financial Services Centers. And this helps the Indian operators, airline operators, to be able to access finance with Indian rupee rates rather than dollar or other international currencies. The government of India, through the Ministry of Civil Aviation, is also looking ahead to set up maintenance, repair, overhaul, which will further bring down the second most important cost element in the operational chain, which is the maintenance cost for airlines. And lastly, as a research lab, as part of CSIR, at NAL, we are pushing for the design, development, and manufacture of next generational regional transporter for India. And so that is how we think this policy will take forward the growth in civil aviation and in turn the growth in the economy. However, as you can very well understand, this is a picture of the NASA climate spiral, a very well-known compilation of the data from 1880s all the way up to 2021, the last year. And you can see that climate change is well upon us. We have extreme weather events, which are already indicating. And what you have here is nearly 1.5 degrees growth in the average kind of temperatures, both positive and negative, particularly in the past few decades, as a result of the usage and the growth of fossil fuels and other kinds of carbon-based fuels. So clearly, we need to do something about this. And this is where, as a research lab, we are looking at alternatives. In the previous talk, you did hear about how we are looking for those solutions for terrestrial applications. At NAL, we are particularly interested in the airborne applications. Typically, if you look at the current worldwide scenario, you have transportation as one of the major energy consumption areas or domains, followed by others. And in terms of the carbon dioxide emissions, for example, again, it is transportation which leads in terms of the amount of carbon dioxide emissions that are produced. And therefore, it is important for the entire transportation sector, including aviation, which forms a part of that, to address this issue. So as I was mentioning, overall, in terms of the share, aviation claims about 8% of the CO2 emissions worldwide. Of course, passenger cars and other kinds of road transport contribute to the larger chunk of that. However, at NAL, we are also conscious of the fact that today, even though goods shipped by air are just 1% by volume, they are about 35% by value in terms of the worldwide shipments. Plus, when you look at aviation today, for distances greater than 1500 kilometers, aviation carries 80% of all the emissions that are there. And on the solution side of things, clearly there have been great market improvements in terms of what today's modern jet aircraft have to offer in terms of fuel efficiency compared to a few decades back. On the other hand, we also see that sustainable aviation fuels is one very good option that needs to be considered to begin with. However, that is not all, and we need to seriously relook at the entire paradigm of how we go about designing civil aircraft in this country as well as elsewhere. So we have three technological elements which are available to us in order to support sustainable aviation. Firstly, as I said, the aviation fuels themselves, the sustainable aviation fuels, SAFs as we call them, that is arguably the first step, clearly because that requires us to do very minimal changes to the infrastructure which is already existing and also the aircraft that we are already using. The second part is clearly we need to target the power plant or the engines which we are using and improve the fuel efficiency even further and reduce the carbon dioxide emissions. And lastly, leveraging new technologies in terms of more electric or the third generation technologies, we need to move over to more or less carbon intensive engines, and also radically rethink the aircraft design itself in terms of the aerodynamics and distributed propulsion and so on. So broadly, the options which are available in terms of sustainable energy are solar, hydrogen fuel based, and also, as we discussed, advanced aviation biofuel. The other option, of course, is to use batteries. However, at the present point, it's very clear that solar based solutions will work only for very niche areas due to the efficiencies involved in converting sunlight into fuel. On the other hand, the most immediate possibility is to use biofuel. Battery technology today, though theoretical efficiencies can go pretty high as about 1000 watt-hour per kg, but then we are more close towards 200 in terms of automotive sector, and very niche battery technologies are touching just about 400 watt-hour per kg. And so therefore, possibly the next option after biofuels would be fuel cells as a potential source for alleviating this the climate change issues. However, when you look at all these sources, we find that for a typical 500 kilometer range, the kind of volumetric and weight densities that can be achieved for a typical hydrocarbon fuel listed under diesel, for example, there, and something like compressed hydrogen at 700 bar, followed by lithium-ion battery. So you can see progressively the volume and weight tend to go up. So we tend to have higher vehicle sizes in order to cater for a given distance, in this case, 500 kilometers. Further, we also have the issue of the amount of time it takes to refill the fuel itself. For example, in case of biofuel, in case of carbon-based fuels, you go to a petrol bunk and fill up the fuel within a matter of minutes. Whereas for other forms, we need to find ways of achieving the same level of refill time. Also, the cost associated with designing, developing, and maintaining these systems becomes crucial. In order to leverage the growth in electrical aircraft technology, we are looking at trying to harness that for reduced noise, for reduced maintenance, and lower emissions, primarily to make the overall system more reliable. And essentially, the idea is to exploit these technology drivers which are now taking shape in the automotive domain and bring them into the aircraft domain. So we need to do this in a progressive fashion so as to leverage what is already existing. So for example, instead of having a fully electric aircraft, one might consider moving over to a more electric aircraft in terms of some of the systems like flight controls, brakes, ECS, de-icing systems. We could, even in electric, we could consider having hybrid propulsion with series and parallel arrangements, and further optimizations on how we utilize the power. And as I mentioned before, we have different fuel sources, which we have already discussed. So we did a quick study for a 90-passenger hybrid electric aircraft where we replaced a larger 2 engines with smaller ones, more fuel efficient traditional engines. And then we had about 6 additional engines on either 6 electric motors actually on either of the wing. And we investigated both parallel hybrid, various variants, and series hybrid. And we did some reasonable assumptions on modeling all of the aerodynamics as well as the potential benefits. And what we find is even at this level where we are mixing a traditional engine, which is burning hydrocarbons, jet fuel, for example, and also adding on electric, partially electric engines, we could see clearly about 45% CO2 emission reduction and a 5% reduction in direct operating cost, which would be direct benefit to the airline operators. And of course, we had extra power at high elevations to take off and land and so on. However, when we looked at a pure electric solution, we found that the battery energy density required for this class of aircraft clearly is not available readily. And so therefore, we looked at smaller aircraft and we found that typically hydrogen would be a potential source for fuel, and it may be possible to modify the current engines to use that directly, of course, for very modest missions of about 200 nautical miles, which probably fall close to the ballpark for regional connectivity. Here is another study which was done in the UK, and this is the Fly Zero concept. And just to give you an idea, they took the ATR 72-600, which is a 72-seater aircraft. And on the 3 columns there on the right, what you have is a comparative statement of how the overall aircraft size worked out. So very similar number of passengers, 72 passengers for a traditional jet aviation fuel in the first column, followed by sustainable aviation fuel in the second column. They had about 75 passengers designed for. And then the last column was liquid hydrogen. So they recommended cryogenic hydrogen for that purpose. And as you can see, they've figured out that it's possible to achieve really zero emission in the near future, perhaps by 2050 ultimately. And so this is what is promising for us also to look into all these aspects. And you can see the configuration is a typical 6-engine distributed one with a smaller wing chord and so on, which is also gives certain benefits overall. At the CSIR National Aerospace Laboratories, we already have 3 aircrafts on the anvil. The first one on the left is the 2-seater Hansa trainer, and it could be a potentially good candidate for all electric. Typically, it's a trainer aircraft, already getting certified to JAR VLA standards. The one in the center is the Saras Mark II. It's a 19-seater commuter, currently under detailed design. And this is something, this aircraft could potentially benefit from, like I said, the hydrogen-based fuel source. And the one on the rightmost is, of course, the regional transport aircraft, which is the 70 to 90-seater, which is currently also in the preliminary design, actually. And that would possibly require a larger intervention in terms of what we are thinking of moving towards alternative sources of power. So to conclude, we've in the last decade become the 3rd largest civil aviation market. So clearly there is going to be a great deal of demand for air transportation in this country. India has very interesting geography in terms of hot and high conditions as well as close to sea level. So large parts of the country can have airports up to about 1 kilometer or so, and we could have larger aircraft flying on those airports. On the northern parts of the country, we have much higher elevations. In some cases, runway lengths are shorter and also higher temperatures. So that always poses a challenge for any aircraft. And as I mentioned in the introduction part, climate change demands immediate action. And it is not just about replacing fossil fuels with different energy sources. It's also about the entire life cycle cost, the system cost, the maintenance cost, the cost to actually design, develop, produce those in large numbers. And I highlighted also some of the policies which the Ministry of Civil Aviation in the Government of India is taking up. In the previous talk, you also heard our sister laboratories, how they are working together for the hydrogen mission, for example. And as I said before, possibly the sequence that will be worthwhile for us, which we are exploring, is sustainable aviation fuel first, followed by some kind of a hybrid engine technology, and then eventually all electric, more electric, including fuel cells. We look towards the electric vehicles, which are available for automobiles, which form a large chunk of the transportation emissions, which come out of the transportation sector. We expect that to spur the technology growth, and we would like to leverage that for aerospace activities. So we have already launched concept studies, as I mentioned before, and we're looking forward to take this, and we invite international collaboration. We hope, or we believe, that will divide the overall cost of development and multiply the overall market size for all these technologies that we have on the anvil. So with that, I come to the conclusion of my presentation, and I'm open to any questions that you may have. Thank you.
Thank you, Dr. Abhay Pashulkar. It was a really eye-opener for everybody that how renewable energy source can be brought into aerospace or transportation area. To all the listeners and viewers, please drop your questions in the chat box if you are attending through Zoom. If you're attending through Facebook and YouTube, please leave your comment in Facebook and YouTube. We will pick up your questions from there. And we are going to have a question, answer, and discussion session after the next presentation, which will be by Dr. B. Chandrasekaran, distinguished scientist, Council of Scientific and Industrial Research. He was a former director of Central Leather Research Institute. He is going to talk on environmental social governance, an example of leather sector. Dr. Chandrasekaran, please.
Thank you, Dr. Basu. Hopefully I'm audible and my slides are visible.
Yes.
Yeah. It's a very good day to all of you. I'm very happy to make my presentation here in the Science Summit at the UN General Assembly 2022. My name is Chandrasekaran. As it was mentioned that I'm currently as a distinguished scientist. I'm going to talk today about the environmental and social governance, an example of leather sector. And being from a leather research institute, and we work towards a sustainable leather manufacturing. But the sustainability, as you see, which has 3 dimensions, which majorly has the environmental to start with, and of course the social. But then you can't just leave your economic sustainability as well. And today, topic, yeah, yes. The highlights of my presentation would be, then it would address not only the environmental and social, but it will also include to some extent the economic aspects in leather manufacturing as well. And as you see, the leather sector currently affects nearly about a dozen of the 17 SDG goals mentioned, whether it is alleviating poverty or gender equity or education that comes on employability, going green, And almost, several of, these things, especially, we work towards that. And this presentation would also highlight some of the success stories of in leather that address directly the environmental and social governance. And we are also looking at the academic research industry partnership that has been practiced by India and CSIR in particular, and also the bilateral and collaborative programs nurtured by CSIR among peers, which has enabled us to serve in that global platform to reach out to many developing nations in Asia and Africa. And in this aspect, I thought, I will highlight some of our technologies for the sustainable leather production. And we have improved and eco-benign leather chemicals for leather production. We have innovations in leather process design as well as development. We also have some of the green technologies, especially using bioproducts such as enzymes and other biocompatible materials and processes. And we also have work in the areas of waste minimization and utilization technologies. And in that process, we also look at some of the development of some of the healthcare products for therapeutic applications. And we also look at the solid waste management that comes into it. In fact, most of the manufacturing sector also looks at the solid waste management, including the bioenergy production, and also development of alternative materials from natural sources. This is basically the hides and skins. The supply of them are inelastic, and we do have always the demand for leather-based products, but that if that is not going to be available, then we have to look for alternative materials, and we work in that aspect as well. When we coming to the leather chemicals and auxiliaries development, where we were in the country at that time in the 80s, the first to produce indigenously the synthetic fat liquors for leather processing from the byproducts of petrochemical industries, especially the fractions of C17, C20, something like that, and where we have converted them successfully into a leather manufacturing chemical, what we call as the synthetic fat liquors. We have also developed during the 80s synthetic tanning agents based on chromium and aluminum with no international equivalents at that time, aiming at high exhaustion at that time. And we also are concentrating on development of high exhaust chrome tanning materials from various sources of chromium, whether it is electroplating industry or from the steel industry and from any other source where the chromium could be obtained and could be used for it. And in that process, we were also developing some of the other tanning agents based on polymers and minerals. Start with some acrylic copolymers and the chromium elements sintans, formaldehyde-free sintans, and the polyurethane-based mineral synthetic tanning agents, what we call. Almost all these technologies were developed from first principles, and these technologies transferred and commercialized. Then coming back to our greener products and green processes, everyone knows the enzyme-based products are available for many of the manufacturing, and leather being a natural material is no exception, and especially a process what we call a dehairing process, which uses conventionally lime and sulfide-based systems, which are known for its pollution loads, as well as generating huge amount of solid waste. And in that, when we use this enzyme-based products for dehairing, and we have successfully reduced the solid waste generation by about 80 to 90%. And many of these enzymes and other green chemicals, we are also looking at them for other operations, what we call as a fiber opening, where the fiber opening, especially the collagen fibers, need to be opened up for subsequently processes such as the chromium tanning or any other tanning, and subsequently the post-tanning processes. And that is being addressed. And this completely replaces even the lime for that matter. And we also have some of the technologies, especially use of non-ammonium based products, basically to alter our pH and other in preparing the material for operations such as tanning and other post-tanning materials, where we could clearly see the shift from a chemical process to bioprocess that's been happening here. And we also have many technology interventions for water conservation, though as a water conservation technology has been dealt in the previous session last week. We have, especially exclusively for leather-based ones, where we have the saltless curing system, we have totally eliminating the use of salt, which is causing one of the major pollution causing substance, which could be addressed directly by abattoirs and other communities, which handles, the meat handling systems, which produces hides and skins, which are taken as a raw material by the tanners. And we also have several end-of-pipe treatment systems, and also several in-process control measures and their process optimization. And we have some technologies, especially for segregating and reusing the wastewater coming out from several what we call the batch process of each of the processes, using a technique called electro-oxidation, and then reusing them seamlessly with other processes. Thereby, we could also use without going to the end-of-pipe treatment options. And also, we have one of the game-changing technology, what we call as waterless chrome tanning technology, and a dry tanning product technology, which addresses the doing chrome tanning without water and also without the use of acid and salt, and which truly a game-changing technology, which nearly fixes chromium about 100%. So that means no chromium is left in the effluent, and thereby giving addressing the major challenge of treatment of these wastewater containing chromium and salt. And many of these efforts, our water saving efforts continuously, which will result now, at least in Tamil Nadu, in this part of the country, where we are almost saving about 1 billion liter of water annually. So all the combined environmental benefit, which is addressing to about 90% salt reduction and 90% water being reused. And in this process, when we standardize this, nearly 8 to 10% of savings on the tanning as well as the post-tanning chemicals. But all this exercise also results in reducing my overall time and the power consumption by about 25%. And the solid waste scenario, India processes approximately about 800 kilotons of raw materials into leather every year. So that means we are now generating nearly about 480 million tons of solid waste per year. And in our opinion, many of our technology interventions could address to 90% out of these 480 millions of solid waste through minimization or utilization of these solid waste into value-added products. As you would see in the chart, and we have the sludge that is coming out from lime and other that gives a large volume. And we also have the fleshing and also the raw trimmings and the other trimmings, leather trimmings, which also contributes nearly about 56%. And these are, some of the major solid waste, that could be addressed. And we have some technologies that, we have developed over the years, especially a footwear soles from the fleshing waste, and also biogas generation, whatever that is possible using the fleshing waste, because the fleshing waste contains fat and other bio products, which could be used for biogas generation or a biofuel, what we call it. And also have technologies for leather thread and fabric and regenerated leather that could be made out of these leather trimmings, and also leather auxiliaries from keratin and the protein-based substances, which are coming out in the form of solid waste during the leather process, as you see. And almost all these are technologies are available, and some of them are even commercialized as well. And we also have, recently some of the significant technologies out of the solid waste, especially a pharma-grade gelatin from a raw material trimmings, raw hide trimming, what we call, and also compost from animal hair waste, and broiler and other animal feed formulations from the fleshing that can be done. And even we can even have a filling material like a road laying material and other flexible composites, what we call as a leather board from the buffing dust and even the chrome shavings. And many of these technologies are at the level of 4 to 5 in the scale of TRL 9. And we have other value-added materials that is coming from hide trimmings, especially for biomedical applications. And we have developed India's first natural immunogenic sterile biological skin in the 80s, especially for burns and wounds. And many of the developments that has happened over the years, now we are in the process of developing even the second generation products of these collagen-based materials, which include the reconstituted collagen sheets with wound healing support systems. As you see here, almost about there are 4, and there are several other dozens of products which are commercially have come out of our technologies and which are being used. And many of our, these collagen burn resin materials have been used almost about 2 decades back when a major fire accident where the children were the victims in a school were treated with our collagen sheets, and you would see their smiles, which is based on our technologies and our contributions. And we also work towards foot care solutions. We all know that the high body mass index develop foot and ankle pain and other musculoskeletal disorders. And we have foot care solutions, especially for the obese and those with flat feet, and even the ankle foot orthosis and other diabetic developed diseases related, complications. And one of our product, what we call, it's a DiaStep, is one of the foot care product for the diabetic, which is already in the market. Through this intervention, we have avoided the ulceration in as many as about 5,000 patients. And even the amputation percentage has dropped from 29% to 17%, using some of these things, which is, we worked closely with the major diabetic hospital here, and we have come out with some of these products commercially for them. We have also addressed some of the problems of the growing feet, especially the children's shoe, where we were trying to address using leather and other composite materials, even the design and the last design and their manufacture to address the issue. Where we could look at giving them a comfortable shoe which would at least last for a year, because the children's feet are growing faster in every 3 months, and sometimes they end up at the middle of the year itself. The shoes or their footwear being out. Their feet are outgrown than their footwear. So we addressed that. We worked in collaboration with the leading footwear manufacturers, and we manufactured more than hundreds of, nearly about 1,000 pairs of these, given to many of our school children, and their efficacy tested, and the results are there now. We work very closely many of the societal development programs. Our programs are a model for an inclusive growth. It starts from animal husbandry, from the carcass recovery and the proper flaying methods, which are all rural-based techniques, and an improved vegetable tanning, a back tanning method, what you see at the right side, a picture, where absolutely a near zero carbon effect. Because there is no machines are used for that tanning process, which are used for many of the handmade footwear. What we call as the footwear artisans we use, and their skill upgradation programs we cover. And one of our success story is turning our Kolhapuri sandals, where we help them obtain geographical indicator, what we call a GI tag. And that product, the Kolhapuri sandals, which were totally of a non-uniform or non-standardized sizes, they were making in the handmade. We have given them templates for various sizes, and also developed some improved tools and improvised models by which some of these the artisans could make their products with the standardized sizes. We brought the families, especially the artisan families, a group of them, to our institute, exposed them to many of these techniques and how to make quality products out of them. We have also indicated them and given them inputs on various colors, trends, and other things that would go with it. We help them participate in the international fairs and securing even the global orders from Europe and Japan. And over 3,000 families in and around the 2 states, basically the Karnataka and Maharashtra borders, the Athani and other villages have been benefited through this. And we not only stopped with that, we also looked at ensuring the sustainability of these activities through a cooperative model by incorporating an NGO to assist them this. You will see many of our this, whether it is carcass recovery or skin removal from devices, the preservation techniques, the back tanning and training, what we offer, especially for the rural training and other things, all of them, addresses, especially the gender parity aspects of it, and in women empowerment in leather. And we have even our leather education, where we offer bachelor's degree and master's degree in with the Anna University. More than 50% of them are girl students who are enrolled for the courses. And in this part of the country, where the leather product industry in Tamil Nadu, we have on an average more than 80% of the workforce are women. And we have some of the industries where almost near 100% all women workforce factories are also available here. They all not only make for the domestic, but they all make high quality products which are being exported to many of the brands. And that is where where this sector contributes to social development through women empowerment. And many of our rural training programs are women-centric, as I said. And this is one such program what we offered in northeastern India, where continuously we keep offering them, and through which we are even encouraging them to become entrepreneurs and employ this. And we also work, as we said before, and other alternative sources of materials to supplement leather. And here, the banana fibers or pineapple fibers and several other fabrics based from natural sources. We try to work with many of the leading design schools like NIFT and NID and develop designs that would have many of these materials in combination that could go with it. And this is one such material with silk and leather combination products. There's another alternative source, what we are highlighting here, the use of chicken feet, converting them into leather finish, as you see here, which has a very unique grain pattern, which that of a reptile skin or something. So though its size is small, but which offers tremendous potential to make quality and top class leather products out of this. And this also gives a lot of involvement of women empowerment, and women could be put to use for making this as an entrepreneur. And also as a cottage industry, they can make these in-house tanning using totally a green processing method and developing panels, which could be made use by many of the corporate product manufacturers to make their products. We also participate in the National Technology Mission with the Government of India, which is spending about $400 million in the last 5 years, where we have developed a vision for Indian leather sector 2035. And we are also conducting several workshops and other various skill-based programs for the entire leather and leather product sector, where we train employees, not only train employees, but also train the trainers, what we call, a pedagogy program. And we are one of the leading institution in pedagogy training. And we also work towards solid waste management, as well as upgradation of common effluent treatment plants and individual treatment plants, where we address how some of these cleaner tanning technologies could minimize the generation of hazardous waste. And we also participate in forming the framework for benchmarking and certification, where the genuine leather mark and eco mark are addressed. And CSIR CLRI, with its vast experience, have our footprints offshore as well. And though since 50s and 60s, we've been participating in several international programs, and where we help many of the developing nations to establish many of the research and other what we call leather institutions in many of the countries in Asia and Africa. And post 2000, we've been working closely in many of the African nations, especially in Ethiopia, where we've been working in benchmarking, which addresses the technology upgradation of the Ethiopian leather sector. And we have also worked closely with a twinning project with an institution in Ethiopia, which addresses the institutional capacity building. And we work with many other nations like Kenya, where the institution building and policy directions for leather sector, Botswana and Rwanda, undertaking a survey and feasibility and giving them the report for establishing leather industry parks, and many other nations such as South Africa, Sudan, Zimbabwe, Tanzania, and several other nations, where we have many of our technologies being given to them with the aim to upgrade as well as participate in institutional building. In way forward, CSIR and CLRI, we foresee an opportunity to contribute to the leather sector through education, skill development and research of the highest order, and implementing many of our activities in the mission mode actionable programs for the economic growth, as well as the environmental sustainability of this industry, say in the coming 5 years. And we foresee an opportunity to translate our knowledge in uncharted areas of Africa and Asia and other nations, by establishing strategic linkages and through engaging UNIDO and their regional offices in Africa and other places for their governmental linkages, and even preparing a compendium of technologies assets with success stories for possible technology tie-ups, and even locating our local champions and institutionalizing partnerships for technology relationship model. With this, I end my presentation and thank you for your attention. I'm looking forward to your queries, if any, for answer. Thank you.
Thank you. Thank you very much, Dr. Chandrasekharan. Very nice presentations showing the gamut of work that CLRI or CSIR is doing, as well as the work that we are doing within India and as well as for the entire world. Now it is time for some more discussion on the three topics that we have covered just now. And I have some questions. I'll just look through the chat box. I think I have questions in the chat box. I would throw this question to Dr. Ashish Lele, who's been working at National Chemical Lab and are also working very closely with our Section 8 company of CSIR Venture Center. How IP protection helping commercialization of research outcomes in India, and how many patents are being licensed or commercialization? That's a very wide questions, but Dr. Ashish Lele.
Yeah. So in general, without a strong IP portfolio, companies would not want to invest significant sums of money, especially in areas such as energy and advanced materials and so on, because once you make an investment, it is necessary that there is a sustainability to the investment made, and that is assured to a large extent when the technology is well protected, both within India and outside India. So in general, our view and our experience is that IP protection actually helps in increasing the confidence of the licensees, and without an IP protection, it reduces the chances of commercialization. So that is my answer to the first question. The second question is how many patents are being licensed for commercialization. The ratios, the exact numbers, I think will vary from lab to lab. In general, I would say that the ratio of patents granted to patents licensed is more or less for CSIR not very different from what global numbers are. And you must keep in mind that those ratios are typically on the lower side. That is, number of patents licensed are far lower than the number of patents commercialized. And patents are not just meant for licensing, they are meant for many other things. Ring fencing is one of the very, very important parts that patents bring to the technology. You may have families of patents. You may be actually practicing only one or two of them, but that entire family protects the technology for you. So ring fencing is a very important part. And therefore, those of you who think that we should not patent inventions because only some portion of that fraction of it gets licensed is not the right way of thinking about it. That's my view on this.
Okay, thank you, Dr. Ashish Lele. I'll go to the second question, which is to Dr. Pashilkar about the low emission aircraft. So it looks like the question is that the low emission aircraft you will come up with, it's a low hanging fruit. And so how we can go about it and what kind of support we can get for such kind of endeavor, support that we get from the infrastructure that you require in the airport or aviation sector in general.
Yeah, so thank you for the question. So the point being made is quite correct in the sense that the airport and airport infrastructure is also part of the ecosystem which needs to address the climate change issues. That's absolutely correct. In fact, I can say that the Bengaluru airport, currently the international airport from where I am talking to you, the city from where I am talking to you, is already carbon neutral. So in the sense that all the vehicles flying there and all the energy consumption that is happening at the airport is essentially carbon neutral. So this is the right way to go, and clearly it is a low-hanging fruit because those are technologies which are readily available and they are being deployed there. The challenge for us in terms of the aircraft itself would be to take some part of it or to develop new technologies which are airworthy in the sense of being able to be put on an aircraft with all the attendant vibration, shock, temperature and other effects which are manifest in terms of the climate and so on. So that's the challenge that CSIR NAL will take up. But clearly, we will tie up with our sister laboratories, both at NCL and IIP. So the next thing would be to look at sustainable aviation fuel, as I highlighted, and then, of course, to new types of fuel cells and other things for which we would have to spend a lot of effort building those engines from scratch, because compared to terrestrial applications, aircraft applications are much more stringent in terms of specifications.
Okay, thank you, Dr. Pashilkar. Dr. Chandrasekaran, I have a question for you. I think the Sustainable Development Goal of UN, if you see all of these from 1 to 17, I think the leather technology and use of leather and all around the world plays an important part, which is not only protection of the feet, but also environmental problems and giving the protection to feed all the poor people all around the world, and to other end is having a high-end product. Okay, so how do you look at it, right? How this can be made as sustainable, and all that linked in this 17 goals? I think leather fits many places, including water pollution to you can talk about sustainability and so on and so forth. So can you just talk about that?
Yes. So see, many of our because this is a material that the hides and skins what the leather sector uses, that the tanneries use, is a byproduct that coming out of a meat industry. So as long as the meat industry exists, and unless and until we find an alternative food source for human, and even in a diversity, especially the animal population, and there has to be, it has to be in alignment with the entire life cycle of the whole systems, and even the animal population is part of a life cycle system. And as long as it is there, and these materials, when the hides and skins are produced, are available for conversion and use as a product. But the challenge, as you rightly said, lies with, while we convert them into a value-added product, if we are in a process of damaging the environment, do we require, and how this could be addressed? And that is where we are now looking towards, wherever possible. There are several things. What we keep doing is, we preserve using salt, and then we remove the salt for the subsequent processes. We add acid and something to make something, and then we remove the acid by adding an alkali. So we are trying to do in the whole leather process, trying to do and undo certain things by adding certain chemicals, and this is what makes the process, the whole thing towards generating pollution. This is where we try to address and try to process them in a what do we call as in a very narrow pH range, that is in the neutral pH range itself. That means we don't need to add salt, or we don't need to add acid and other things. And if you don't use, or even if you don't use much of water. So if we develop some of these processes based on this, which will work effectively in this, then we could also address to it. At the same time, avoiding certain chemicals which are causing solid waste and other things. That is where we were trying to use some of the biological options. The whole aspect of it, in my opinion, this is all, sometimes what happens, a certain batch processes are done in one country, and subsequently as an intermediate material, it is transported to another country where they process. That's where the challenge of adopting many of these greener process solutions or the technologies in toto might be missing right now. But when we address these things to many of the other developing nations, whether it is in Asia or Africa, and all the other places as well. Then, I mean, of course, the uniformity will be coming in the form of leather production. I think many of our UNDP documents in leather and leather manufacture, we try to come out with the SOPs, especially, I mean, how to and what to do and what not to do. And we also participate in many of those exercises in preparing the international standards in various processes. And I'm sure if we don't process and leave some of these hides and skins to putrefy naturally, the carbon effect, I mean, that comes out of such an exercise is much larger than, I mean, what we do, I mean, the process and then make valuable products. And especially if we address this, we are in the process of going towards sustainable manufacture.
Thank you. Thank you, Dr. Chandrasekaran. We will now go to the next set of speakers. We are starting a new session or part of this session, which is Industry and Infrastructure, Materials for Global Society. We are dealing here SDG 8, 9, and 12 and many more. We start with the first speaker, Dr. Indranil Chattaraj, Director of National Metallurgical Laboratory, and he's going to speak on materials and applications, both for non-conventional and secondary resources. Dr. Chattaraj, please.
Thank you, Dr. Basu. Is my screen visible?
Yes.
Thank you so much. Ladies and gentlemen, a very good evening, and it's my privilege to be presenting the CSIR initiatives on materials and applications. Typically, we target 4 different SDGs, which will become apparent as I go through this presentation. I am the Director of National Metallurgical Laboratory. My name is I. Chattaraj. Let me start by indicating to you the life cycle of a material. The life cycle of a component typically starts with metals extraction or materials extraction, followed by manufacturing, then distribution, then usage, and followed by end-of-life management. In 4 out of these 5 phases in the life cycle of a component, CSIR has definite interventions and innovations. For instance, in materials extraction, we are looking at green alternate technologies. We are looking to reduce carbon footprint. We are looking to minimize or recycle waste. Similarly, for manufacturing and distribution, we have interventions. And of course, for end-of-life management. In fact, a lot of my presentation today will talk of end-of-life management of components and materials. Before I move on to my technical slides, let me discuss a little bit about CSIR capabilities in the area of materials. If you look at CSIR as a whole, we have at least 12 different research units. These are pretty large units. These are either laboratories or institutes. And nearly 900 scientists are there doing materials and metals research all across CSIR. We have approximately 130 active patents as on date. We have technologies of around 76 which have a TRL of more than 6. Out of these, there are 14 technologies which have a TR level of greater than 9, which essentially means they have been commercialized. We receive most of our external funding on materials and metals from industries, and our funding typically in an annum for CSIR as a whole is of the tune of $40 million. If you look at the domain areas that are pursued at CSIR, we cover practically every aspect of materials. When I talk of materials, let me also clarify here that I'm talking about metals and ceramics and similar materials. I will largely avoid organic materials and also touch only very briefly on inorganic materials. So the domain areas include ceramics, glasses, a number of processes which are important in metals extraction and mineral beneficiation, industrial waste, alloys and composites, and so forth. Let me start with lean ore processing, an activity in which CSIR has been involved for at least 60 years, over the last 60 years. The need for lean ore processing today is much more relevant than it ever was, because we have very indiscriminately used up all the high and medium grade ores, which were essential for metal extraction. And therefore, we now have to resort to low grade ores, which are essentially leans. And the CSIR work plan in this regard are in 3 different directions. One is on processing the actual lean grade ores. The second is processing of slimes. Slimes are nothing but is like a watery sludge containing the minerals, which are generated both at the mines as well as at the mineral processing units. We are also looking at processing of low-grade fines, which are generated at the mines and are very difficult to work with in commercial production of the metals. If you look at our portfolio, we have carried out around 1,000 investigations on lean ores in different institutes at CSIR. If you look at the majority of industrial processes which have been set up in India on mineral beneficiation, they have been set up using CSIR protocols and technologies. We also have a very good international presence. Nearly 100 international clients have benefited from the protocols and technologies which were developed by CSIR. To the right of your screen is a pictorial depiction of the different countries where CSIR technologies have been used. We touch at least 4 different continents, countries in 4 different continents with our mineral processing expertise. Continuing with lean ore processing, this is typically a flow sheet for 2 different lean ores. The first one on your left is for lean ores of iron. I'm not going to go into the unit processes which are involved, but let me emphasize that they are quite involved processes, and we end up with high-grade concentrates. The one on your right is for a graphitic ore. Using CSIR technologies, at least 8 different commercial plants are running for low-grade iron ore processing in India. We also lay a lot of emphasis on utilizing secondaries. For India specifically, secondaries can be a very important source of metals. And on your right, you'll see the advantages of using secondaries. For instance, if you're trying to produce 1 ton of lithium, you'll need nearly 250 tons of the primary ore, which is spodumene. Or if you're producing from brine, you'll need about 750 tons of brine to produce 1 ton of lithium. On the other hand, if you use discarded lithium batteries, end-of-life lithium batteries, only 28 tons of lithium batteries would be needed to produce 1 ton of lithium. The same is true for cobalt, for nickel. All these are strategic metals for India. In fact, these are metals which are only found in certain pockets across the world and are strategic for a number of other countries. And the importance of these stems from the fact that electric vehicles are going to become more and more popular. In India, for instance, we are generating nearly 50,000 tons of lithium battery at present, lithium battery waste at present, and this is expected to at least increase 3-fold by 2025. The achievements of CSIR in the areas of values recovery from lithium batteries are manifold. We have tested all possible chemistries of lithium batteries. We are able to produce 96 to 99.9% pure metallic elements from these discarded lithium batteries. A number of other value-added products are also recovered from the discarded lithium batteries. Moving on, another secondary, which is of great importance and which is, of course, considered a waste in its present form, are electronic waste. If you look at the different categories of electronic waste, like devices, batteries, magnets, opto devices, all which are discarded, all which have reached their end of life, there are a number of valuables which can be obtained from them. and we exploit that. We use our extractive technologies to produce valuables, and some of the products are shown on this pictorial depiction of the products on your right, on the right part of the screen. So we do produce a number of metallic salts. We produce pure metals. We produce chlorides, oxalates, and different kinds of metallic compounds, which are all valuable, which can all be commercially sold. Based on the e-waste recycling technology of CSIR, at least 20 different entrepreneurs have set up their plants in India. Industrial waste of any kind, which has any values, especially metallic values, we have a technology to extract that metallic value from it, and quite often techno-economically viable in every sense. A number of technologies have been developed as well as transferred to licensees on industrial waste. And the industrial waste that we have exploited are indicated in red on the left-hand part of your screen. For instance, we have developed technologies from fly ash, from copper slag, from ferrochrome slag, from iron ore tailings, from red mud, pickle liquor. You name an industrial waste which has metallic values or which has substantial metallic values, and we have a technology to extract values out of it. For instance, in the case of fly ash, we have been able to convert it into bricks, refractories, different kinds of ceramics, paving blocks, road materials, synthetic cements. And on the right-hand part of your screen are a number of industrial applications of the different industrial waste that we have valorized. Another important initiative that has become very important from an Indian perspective as well as a world perspective is the production of green and clean steel. At CSIR, we follow the philosophy of hydrogen plasma smelting. And using this technology, we have been able to produce steel. And the USP of this process is that it is significantly less energy consuming compared to other commercial processes. And the second important USP is, of course, it produces much lower pollution. And this is a technology which can be piloted if a suitable commercial partner is willing to come forward to take up this technology. At CSIR, we have been able to produce a number of composites. We work on particulate composites, on fiber composites, on laminated composites. On the right part of your screen are the different products which are made out of these composites. We produce helmets, manhole covers. We produce different kinds of separation membranes, connecting rods, aluminum graphene composites, and so on and so forth. We quite often use a number of different industrial wastes and convert them into composites. For instance, we have used fly ash, marble waste, stone, granite, and red mud, and converted them into useful composites. Our products portfolio in composites includes high strength, lightweight, sandwich, as well as glossy composites. Many of these technologies have been licensed to multiple parties. Bioimplants is another important development in CSIR. We have been able to develop and commercialize integrated orbital implants, bioactive granules, as well as scaffolds, hydroxyapatite coatings. We also have a ZTA technology. We have magnesium-based bioimplants. The different parties, the different licenses are indicated in parentheses against each of these categories of biomaterials. An important aspect of Industry 4.0 is the development of sensors. And at CSIR, we develop sensor materials as well as make sensors out of them. Here is a representation of the fiber Bragg grating sensors that have been developed by CSIR, by different laboratories in CSIR, and how they have been put to use. They have been used in intelligent pantographs for railways. They have been used for health monitoring of generators. They have been used for critical hot zone prediction of blowpipes and blast furnace. And in the first time in the world application, our FBG instrumented mold has been used for predicting as well as preventing breakout in a billet caster. A billet caster is an instrument used in continuous casting of steel. Apart from fiber grating, we have a number of other process sensors. The ones indicated here, which are outlined by red, are all process sensors. So we have magnetic sensors, eddy current sensors, visual online sensors. All of the sensors which are indicated here have been commercialized. For instance, if you look at the visual online sensor, this has been transferred to a major steel plant in India and is in operation. We also have a number of biosensors like a diabetic breath analyzer, as well as sensors for detecting trace pesticide in food. We also have humidity sensors. And in sensors, CSIR has been able to capture the attention of definitely the Indian market. We have a number of devices which have been made, which are unique. For instance, CSIR has made Raman spectrometers, and these Raman spectrometers are possibly the cheapest that are available anywhere in the world. These, of course, have been validated. These have been codified. These have been tested against all codes and practices and have been found to be optically designed for maximum spectrometer throughput. These spectrometers have been commercially produced by a partner. We have also produced lead-free X-ray shielding tiles. For this, we have used red mud, which is another industrial waste and which is produced in copious amounts in India. And it's a menace. We have been able to convert it into shielding tiles, and this technology has also been licensed. This is the last item that I'll be talking about, and these are coatings. Our coatings are based on innovation, they are trend-driven, they are based on market demand, and of course, we do pay a lot of respect to sustainability. With all these, we have been able to develop different categories of coating, including super hydrophobic coatings, antimicrobial, smart coatings, transparent coatings, polymer coatings, and so on and so forth. Here are some pictorial representations of the different coatings that have been developed at CSIR. That's all I have to share with you regarding the different materials and their applications across different CSIR laboratories. Thank you. I'll wait for any questions that you might have. Thank you very much. Dr. Basu, I'm done.
Thank you, Dr. Chaturaj, for a nice presentation talking about the circularity or the recycling of waste that is generated, and as well as in the plant level, the waste, the industrial waste that is generated. We'll come back to on discussion session on this. We have now the next presentation on infrastructure by Dr. N. Anandavalli. She is the Director of Structural Engineering Research Center at Chennai. And I would request Dr. Anandavalli to start her presentation. Thank you.
Yeah, thank you, Dr. Basu. Are my slides visible and am I audible?
Yes.
Yes, ma'am. Yeah. I'll be just talking another 15 minutes on what CSIR's Civil Infrastructural Engineering team has contributed and aligned themselves with the United Nations Sustainable Development Goals as they address the nation's missions. So if you see the basic necessity of any human, basic is food, clothing, and shelter in the form of housing. That is where civil engineering comes into play, and civil engineering exists in all walks of life. So as we move with the shelter, it should be safe, sustainable, and environmental friendly. While after the shelter, mobility is what we require, and that to be planned and durable by the ways of roads, bridges, railways, waterways, airports. And also these infrastructures which are built, which sectors invest a lot of money in that, government also invests a lot of money, that has to be monitored to prevent any unwanted events, and also to mitigate the natural and man-made disasters. These are some of the requirements, and also we need to automate for fast implementation of these technologies, whatever we are developing. And finally, the waste, we have to address waste generation from the construction industry, how to address this. These are important areas. And as we see, this particular theme is from energy to environment, covers and materials to infrastructure and sensors to robotics. So we have aligned ourselves in 7 thrust areas. One is on the building physics and materials, because this is much required to understand what kind of mechanism is there and how to plan for it, and also the relevant materials. The second one is the rural infrastructure, which addresses the needs of the rural population. And the third one is on the mobility infrastructure and planning. So as I told, mobility is required for the supply chain and other areas, related areas. Automation and robotics for fast implementation, waste to wealth. This is what we address, the waste generation from the construction industry. And the structural health monitoring and life extension, that is what we address through how to maintain our structures and periodically check them through innovative technologies and disaster mitigation. So infrastructure, as we see, the global thing, 14% of the global GDP goes for this development of infrastructure. And also every year through 2035, there is a need for investment of about 3.7 trillion US dollars for developing the infrastructure and to maintain the projected GDP growth. And also UN's Sustainable Developmental Growth, to achieve this, we roughly $1 trillion US dollars are required to meet these goals. And the housing sector alone needs a total investment of $9 trillion to $11 trillion by 2025. So keeping in this the global scenario, CSIR team has kept the focus on sustainable infrastructure, and we see it as there is a huge demand and also enough opportunities for development of new technologies. And the unique advantage of CSIR is that we have the complementary expertise and also the interdisciplinary approach. The platform to synergize and channelize the expertise to address the SDG is also available with the CSIR. So with this, we align ourselves with the United Nations Sustainable Goals while we address the national priorities such as Swachh Bharat, Atal Mission for Regeneration and Urban Transformation, and Smart City, Jal Jeevan Mission, and Skill India. These are national missions that is in alignment with the UN Sustainable Developmental Goals. If I could see what the CI team can contribute directly, there are 3 things which we can contribute. One on the clean water and sanitation, innovation and infrastructure, and sustainable cities and communities. While the other things are also there, like climate action, because due to climate action, there are some impact on the infrastructure, and we need to address and re-engineer in a different way. And also quality education. Through this program, we can enhance the skill, and then through that, we can help them get employment, and also skilling and reskilling. Unemployment will prevent will address the no poverty and no hunger. And these are different laboratories that work on this particular theme. There are 5 different laboratories which address this in addition to the other laboratories. So coming to the building physics and materials, if I could see the 3D printing of cementitious composite elements, that is what we concentrate, and we try to develop the composites, cementitious composites for the 3D printing. That is what we concentrate and try to develop a modular printer. And also towards nearly net zero energy buildings, the planning, design, and technologies are available, and ultraviolet ventilation, due to this COVID, this development was happening, and also textile reinforced concrete for infrastructure application. As we can see in this slide, the crash barriers, tiles, canal linings, wall panels, and even the water tanks, which towards clean water concept, these products are from the TRC. And while we align ourselves with the SDG goals of sustainable cities and communities, climate action and clean water and sanitation, our future areas which we need to collaborate or join hands with some of you is on the development of multifunctional composites and also construction chemicals for cold weathering concreting, circular economy in construction materials, low cost carbon sink materials, and surface coatings for various applications, and use of FRP in structural engineering applications. So coming to the next thrust area of rural infrastructure, we could demonstrate the bamboo reinforced concrete structure for low cost housing. This is real actual size scale building which has been demonstrated using the bamboo reinforced concrete. And also we address the agro waste building products, from the agro waste to building products. And towards skill development and training, we conduct number of courses and also empower the women and the rural population to take up some of the products for their livelihood. So we address through this good health and well-being for people, clean water and sanitation, zero hunger, and the future areas which we would like to concentrate and join hands with you is on the solar powered cold storage for agricultural products, which is very much needed to protect, preserve our agricultural products, and post harvesting technologies for a highly humid environment, and agricultural wastes to value added products. And the next thrust area is on the mobility infrastructure. And India's first steel slag road was demonstrated. And through this technology, the conventional road thickness is reduced by 30 to 40% and the construction cost by 30%, in addition to the high durability and improved service life. And there is a textile reinforced concrete fencing panels, which is very easy to build and lay. And this is particularly suitable for highways. And demonstration of that was done in the laboratory scale, and we have also transferred this technology to one of the construction company, and it is being implemented in a highway. And the noise mapping and noise barrier design, this is also which we concentrate. So our focus area will be on cold mix technology for high volume roads, and drone based technology for safety audit, and control blasting techniques for tunnel construction, and high speed rail feasibility that studies will be carrying out in future. Coming to the next thrust area on automation and robotics, which is very much essential in the area of civil infrastructure. One is on the mechanized sewage line cleaning system, where this is addressing different modules, like one for the narrow lane and small dwellings, and the other one for the townships, and also for urban and local bodies, a different module is available. And the advantage is that it is integrated with the high power slurry pump and water jetting and multi-stage filtration unit for slurry water and grab bucket. And the water is also recycled. And also subterranean robots are available. And the salient feature of this development is that it is capable of exploring the full tunnel. So it is adaptable to any terrain, all terrain capability, and also useful in locating trapped miners. These are a few of the developments, and future area which we would like to connect and collaborate is on fully connected and intelligent systems and digital twin for in-situ certification process, and human-friendly robots for medical, industrial, civil, underwater. Particularly this underwater, if you see, there are structures which are under the water which we need to be monitored, which this kind of robots will be very much useful in that. And power electronics and battery charging functions, these are some areas. And also robots for unknown and unpredictable environment. Coming to the next on the waste to wealth, So one particular example is that agro waste. If you see the agro waste that is being burned, which is not in, causes hazardous to the environment, and when we convert this into a useful product, the parallel particle boards are developed, and also with the inorganic industrial waste also we develop the composite wood. These technologies are available, and conductive concrete using bangashash. These are three different products that is available from this waste to wealth subvertical. And future areas, we would like to concentrate on geopolymer concrete for fast track construction, and concrete utilizing the industrial solid waste such as recycled tires, plastic waste, sludge. These are some areas which is not being addressed right now. And coming to the next vertical on structural health monitoring, the CSIR technology, which has made an intervention, and this forerunner technology, which is accomplished internationally also, is on innovative technology to evaluate the longitudinal force for different types of railway bridges. And there is a particular instrumentation scheme and multi-sensor based techniques for real-time performance evaluation of railway bridges. And this has come out of the CSIR's effort. And the technology for evaluation, mitigation of the effect of longitudinal force. One is the evaluation of the longitudinal force, then the mitigation of the effect is on the substructure is also available. Also, this enables the quantitative evaluation of tractive and braking force during the passage of train overbridge. We are pioneer in this, and we would like to collaborate in the future areas which we would like to concentrate is on the non-contact SHM and the baseline free algorithms for SHM, because this particular SHM where this is baseline free algorithms are required, because we don't know some of the existing structures, the baseline data will not be available. So with the current data, we have to build up the algorithms for structural health monitoring and data-driven methods using AI techniques. This is where huge amount of data will be available, and that will help us to give solutions through AI techniques and cybersecurity measures, and also integration of Internet of Things towards infrastructure. So also aging infrastructure, where we need to concentrate on either condition assessment, life enhancement, and performance-based retrofitting. These are the areas for the aging infrastructure we would like to address. And coming to the disaster mitigation, we address both man-made as well as natural disasters. We have got few technologies, say for example, replaceable fuse link element, which is currently patented, which has got a unique fuse link element which absorbs the energy of the earthquake, and the elements, steel frame elements, can be reused in case of the event occurs. And also the magnetorheological elastomers, the smart seismic and vibration isolators. This is under development, and in the near future we will come up with the technology. And the one particular technology from CSIR, which is cost effective, is on the emergency retrieval system. This particular technology is suitable for 33 to 800 kilowatt transmission line towers, and it helps in the quick restoration of power in the event of transmission line failures. So this has been transferred to one of the organization here, and they are started manufacturing this, and the entire unit can be taken in a truck and then assembled quickly, and 2 patents have been filed on this. And this is a ready-made technology which is available, which can be transferred immediately. And future, we also address how we develop resilient societies. So the concept now changes from damage prevention to continued operation, and also new areas like such as metamaterials for seismic protection and performance-based wind engineering. These are new areas of research, and we would like to focus on different areas and collaborate with some of you on modified tunnel blast design and structural re-engineering to address climate change and advanced weather and climate modeling and its impact on different sectors. and also to assess the environmental pollutants and sensors development thereof. So I would like to highlight upon some few of the technology portfolio which we are readily of different TRL levels. This is one particular one which is suitable for makeshift hospital. This was a development during the COVID period, and this structure can be folded and then taken in a truck and assembled. And not only for makeshift hospital, it can address other small houses or during disasters. We can take these and then assemble and create immediate shelters. And textile reinforced cash barriers I have already highlighted. This has been tested also in the factory level, and TRL 5 is it is under TRL 5, and some more developments we'll be taking up some more research and development so that we can transfer this technology. And the Indian rebars, threaded anchor bars, which we have developed and which can be adaptable for any other rebar also. Geopolymer concrete blocks. This is again from the waste to wealth, and precast lightweight panels for mass housing. This is a demo building, and number of such installations are available. And textile reinforced concrete, different products are there. One is on the prototyping technology itself is available, and emergency retrieval system for power lines. These are different technology portfolios available in the CSIR. And this again shows a slide where different technologies that are of different TRL levels, and we are working on it to convert it into a transferable technology. And I would like to conclude with a Thirukural, which says that which means that where there is a clear way to perform, aim for excellence, and if there is no path, search for new ways to accomplish the work. That is what research is basically. Thank you, and I'm open for discussion.
Thank you, Dr. Anandavalli, for a nice presentation covering all the work that SCRC is doing. We now come to the question, answer, and discussion session. We have a question in the chat box. I think probably Dr. Chattaraj will answer this question. Any work in nanomaterial? This is by Dr. Raghu. Any work in nanomaterial? Any work on anti-counterfeiting technology for products and supply chain security using Industry 4.0 technologies?
Nanomaterial I've kind of avoided making a presentation on, because whatever technology CSIR has on nanomaterials haven't reached TRL 9 level. Nanomaterials are of course being explored for a variety of applications across CSIR, and so are 2D materials. In fact, right now the flavor in CSIR is more on 2D materials than nanomaterials. But for nanomaterials, we have a number of device applications, including sensors. We have magnetic devices made out of nanomaterials as well. But like I said, that they have not reached a sufficient TRL level yet in CSIR to be brandished about at this point in time. We do have a lot of work on nanomaterials, having said that.
We have one more question, Dr. Chattaraj. The materials are designed, I mean, there's a concept of circularity. You talked a lot on circularity and circular economy in your presentation. So we are trying, whatever is designed and whatever is made, we are trying to actually recycle it after extraction or refurbishing it. But there's also a concept that you design your material for circularity. That means you design such a way, especially in the material area, that it is recyclable and causing less environmental damage while you do so. So that concept, I'm sure we have not utilized much. Those are material designer or functionalization and then use it. That's what we have looked in. Maybe the cost was the issue that's looked in, but not the circular part. So can you throw a light on this?
Yeah, a very good suggestion. Actually, tailoring material to be more sustainable. However, what I have talked about are mostly secondaries, which were not tailored in that fashion. So whatever is available as on date are not necessarily materials which designed with sustainability in mind, possibly. So the secondary resources I'm talking about are mostly resources which are commercially available as on date. But a very good suggestion. That's the way it should be. I agree with that.
Okay, thank you, Dr. Chattaraj. Dr. Anandavalli, would you like to throw on modular design? I mean, I know you talked about it already, but bringing modularity, in, especially in Indian homes and home across the world, and having less and less environmental damage, bringing modularity in design or construction, which is already done in India. But I'm looking at sustainable homes. The folding or folded houses, all these concepts are there, but keeping in mind the cost and the work that is done in SCRC, can you throw light on this? You are muted.
Sorry. Prefabricated houses or prefabricated structures where we have more quality control, like wastage is also minimized. Actually, when we take it, most of them is made in the factories, we can have better quality control and less of wastage. And I think that will also enable us to build quicker, like a faster implementation of the thing is available. Cost effectiveness is when we see as a developmental thing, it is very expensive, but when once it is being practiced and put into, if you take the whole life cycle, maintenance free, all those things, aspects, if you see, it is really cost effective. And to address the needs, immediate needs of the country, it's very much required, the modular construction. And standardization, because that will have a more easy design where we can have multiples of, for mass housing and other things. This is a better option rather than in situ.
Thank you very much. There is a question in the chat box on terahertz characterization capabilities. Yes, CSI do have these facilities. We have National Physical Laboratory, and many other laboratories do have terahertz characterization facilities. So we end, because of the paucity of time, we would end the presentation session, but we do have now a concluding session, a panel discussion. So I would request Dr. Sriram to take this forward, the concluding session. Dr. Sriram, please.
Dr. Basu, thank you very much. And thanks for the fantastic session that we had. So to start off this session, may I just check out, because I see a lot of people having joined in. So I'll just check out whether the panelists are here. I can see Dr. Ramshakarma is there, Dr. Tiwari is there, Dr. Dhananjay, have you been able to join us? Mr. Declan is available, as I can see. So I hope Dr. Dhananjay would be able to join us at some point of time. But anyway, I think we'll just keep going. So the way I would like to go forward for the panel discussion is that we would like to pose two questions each to the chairpersons of the previous sessions, Dr. Ram and Dr. Basu. And then subsequently, we'll pose a question each to other panelists. So let me kickstart this process by asking the first question to Dr. Ramshakarma. Sir, as we go through the chat boxes and other discussions on 22nd, it looks like the SDG goal of no poverty and zero hunger is a tall task, especially in the context of non-availability of land, growing population, economic considerations, etc. So how do you foresee that the CSIR SNT activities can meet these goals at an international level, keeping in mind these constraints as well? Dr. Ram.
Yeah, thank you. Before I answer this question, I will make one sentence that sustainable development goal require sustainable investment of all kinds of sciences and technologies. And I think India has shown this since independence, that if you look back, majority of the major problem of India, they have only been addressed by scientific, medical, technological interventions. And I think the poverty and hunger, both are intertwined. And some of the programs that we talked about in the first session and this session are actually towards those objectives. As far as zero hunger is concerned, I think all of you will appreciate that today, globally, we have surplus food, all kinds of surplus. We are surplus globe. Our problem is not more wheat, more rice. Our problem is equitable distribution. Our problem is management. 30% or 40% of horticulture, agriculture produce simply goes waste at the time of processing. And then equal amount is wasted during the where it needs to go, transport and end user. So I think we need more innovations, and I think those innovations are happening, at least to start with high value products. So I think that is something is important, that we have to focus more on resource mobilization rather than going for deforestation and increasing more agricultural land, that we are heading a very wrong direction. And this, as far as the poverty is concerned, poverty is now, we have seen in our country and other countries, a lot of poverty is because of displacement of people. People's livelihood, where they are born, they are uprooted from their livelihood and their culture. So there is a double problem of large number of, particularly in developing countries and in even developed countries. For that, I think again, some of the projects of CSIR and other scientific agencies globally, that we have to use now knowledge which is available to us to provide high value cash crop output to local where they are. Like, for example, India has a huge Himalayan zone, coastal zone. Why can't we use the local renewable resources of the sea? Now there is a talk about sea farming. Sea is going to be the next source of the food, unlimited source of food, provided that we utilize those properties. So instead of deforestation and increasing the land, second point I will make, which is linked to both these things, like India, we have only 40% of irrigated lands. And 60% is non-irrigated land. Out of that, 20% is fallow land, but rest is very, very productive land. For example, on Himalayas, like look at from northeast to Jammu and Kashmir, there is a huge hundreds and hundreds of square kilometers of land which are under forest cover. And I think that could be a sustainable way to produce materials which are of very high value. So I think what CSIR is working, for example, both these issues can be addressed by diversification of the crops. I think we have given overemphasis on rice and wheat because staple food. But I think there we have gone surplus. Now we have to at least introduce 20 to 30% cash crops. And like, for example, effort like Aroma Mission, Phytopharmaceutical Mission, Floriculture Mission, if you really analyze their import, is actually towards that. So if a small farmer has 70% land makes his food, but 30% if he grows a particular high value crop, for example, rose, he can get some cash money, and that money will help education, hunger. So I think some of these mission programs which are addressed towards society, but these missions will require new science. My worry is that we are not doing enough breeding experiment, we are not developing enough variety, we are not using new tools of genomics. For that, I think that is where we have to continue to invest heavily in high fundamental science to improve these qualities. And I think those are the issues. To me, issue is not for producing more, issue is managing and creating a global equitable distribution system. Some countries are sitting with surplus, some countries are dealing with hunger. And Africa is a classic problem. I think it's a purely, global responsibility of United Nations and lot of bodies. I think they have to relook again, rather than old sort of Bretton Woods model and IMF model. I think there are new models and they are evolving. And I think that's what my view that, but I will conclude that major differentiator in this addressing this problem, India and outside, will be only through science, innovations and translation. Thank you.
Thank you very much, sir. So let me continue with Dr. Basu on this mission mode projects, which Dr. Ram did mention about. We do have some mission mode projects on energy, water, and those kind of things. And let me take a specific case of the energy mission. How do you foresee that the mission mode activity that we are doing in India can be taken to other countries, especially in the, the background of COP26 and other aspects?
I think it's a very relevant question when we are talking about SDGs. By nature, the mission mode project is you are defining a project, you are working on a project which we take to the end, and it would obviously be translated or obviously be implemented. In the energy sector, we have a couple of mission mode projects happening in CSIR. There are many ways to do it. It's starting with Nibidly project that we had on fuel cell, or we had on storage, lithium-ion battery, or TAPSUN. To say there are many on the renewable energies. Specifically, we were concentrating on renewable energy from the last 15 years or 20 years or so. And we have done a fantastic job. And we just came to know today that that what we have done in the energy resources area, and this mission mode project, both in the fuel cell, hydrogen energy, which is currently going on, and that platform of lithium-ion battery pilot scale demonstration that we have already come up with at Chennai, and so on and so forth. There are many such things are done at the CSIR level. And we were working always with the industry. So even all mission mode project, we do have, I'm not just mentioning the names, but we do have corporates or the industry along with this mission mode project who are participating in the mission mode project, and then finally taking the project. So from the very beginning, hand-holding is very important. And not only just work alone in our lab, but in the mission project, we are actually talking with the industry, and they're visiting us, and we are working with them and hand in hand, and not that they are just observer, and then taking this forward. Now, in the global context, the same model, of course, work. And there is a huge potential of our, especially the energy sector that you talked about. I mean, I'm concentrating on energy and climate change because they are linked. And then we have a mission on CCUS, which is currently also running, which is very important, as we have to, by 2070 or 2050 or 2070, India, the Honorable Prime Minister already said that we will be carbon neutral by 2070. So COP26, we have already committed for that. And all this project that coming from the solar photovoltaic to the energy storage, then alternative sources, biofuel that we have already talked about today, all of these, of course, the goal is towards the carbon neutral. Having said that, one point I would like to mention that which we have not covered, but a country like India, I think we need to have less and less import of energy resources, like we do it for crude or gas. And we have plenty of internal resources, which is coal, and which is high ash coal. And there are also a mission on this, how clean coal technologies can be taken forward or can be implemented while we generate methanol or DME that we talked about today from coal, but yet with CCUS, that means you are doing the utilization of carbon or CO2 sequestration and utilization and storage. So once you have a clean coal technology with CCUS, this is very beneficial for India. We will abide by the COP26. At the same time, we will use our own resources, and we can really bring down the import of the crude and the gas. That is a big exchequer for our revenue department, revenue sources. So we are looking at a mix of energy source, and which is beneficial for India. Definitely renewable energy, the wind and the photovoltaic, coupled with the sodium-ion and lithium-ion battery for storage, with the hydrogen energy storage, with the splitting of water using photovoltaic, and then using a fuel cell using hydrogen. And so these are the, and then area of aerospace as well, it was mentioned. So these are the areas we are looking at. And I'm sure by 2070, we will be carbon neutral, along with all this mixed bag of energy resources.
Yeah, thank you very much, sir. So let me take from Dr. Ram and go to Dr. Tiwari. Dr. Ram mentioned about the fact that we need to do a better resource mapping, and that's more important. And I do understand that in CSIR, we have been looking at various advanced technologies for resource mapping. So, Dr. Tiwari, can you put it in, say, layman's perspective, a common man's perspective, how we can use the resource mapping techniques for the better attainment of the requirements of the common man? Dr. Tiwari.
Thank you, Dr. Sidam, and once again, greetings to all the participants joined through online media. We are very much aware that society's greatest challenges are directly or indirectly linked to the natural resources and the consequences of them, particularly when we talk of mineral and energy resources, which are major contributor to any national wealth and economy. And parallelly, when we take the other natural resource like water, has a direct impact on food and ecology. Therefore, if we are able to trace the locales of these resources properly and manage them, they will be very important in the long-term sustainability of the humankind. Over the years, almost over the last 80 years, since very beginning, CSIR has realized the importance of locating our Mother Earth's resources and making the models, forecasting them for the sustainable exploitations. And therefore, several research institutes like National Geophysical Research Institute, National Institute of Oceanography, National Environmental Engineering Research Institute, they all got engaged in exploring and also developing the new technologies that can precisely explore as well as provide a sustainable management solutions for exploiting them. So in summary, what I am trying to say that still the Earth's natural resources remain to be very vital for the sustenance of the technologies and also meeting to the targets of the sustainable developmental goals. In terms of the development of the technologies and in terms of our knowledge base, which can be applicable not only for the countries like India, because we see the kind of the geological terrains, they are spread all over the globe, whether it's Africa, whether it is Australia, or whether it is United States or Europe. And these techniques which we utilize and have got the experiences and expertises can be beneficial in targeting these resource materials from the earth. And therefore, what we are doing for our country, addressing the national goals where we talk of the water for billions of people of this country, safe drinking water, and also the water for the agriculture. We parallelly talk of the energy minerals. And now when we talk of them as a green energy, we are locating the minerals like coal that can be converted from coal to the other form, which will be less harmful to the environment. Similarly, we also have the experiences of finding the atomic minerals, which are one of the best source of generation of the clean energy. And recently, CSIR, NGRI, and CSIR NIO had worked on one of the very important energy resources, generally called gas hydrates located in the continental shelves of the Indian coast. And we can see that the kind of the volume of those resources available can meet the large energy demands, which is ever increasing, not only in our country, but also in the other parts of the globe. And with this, I would like to say that the way we are proceeding, we are not only thinking of the major goal of United Nations SDGs, where we talk of the people, prosperity, and planet, and we will be able to address all these issues within the country and outside the country. And I'm very pleased to be part of this discussion, and we'll have any kind of further engagement with any of you who are joining on this platform and can provide the specific knowledge base what CSIR has developed, adopted, and implemented. Thank you, Dr. Sridham. And I'm
Thank you, Dr. Tiwari. I'll possibly come back to you again. I go back to Dr. Ram because there was one question in the chat box which asked the question, how does CSIR look at converting brilliant science into translation? You had led the COVID mission for the CSIR. So taking that as an example, can you please tell how the translational research in CSIR works and what is the success model for behind it?
Yeah, so I think if you look at CSIR like body, it occupies a sweet spot. I call it sweet spot between universities and industry. And countries which are not able to realize this triumvirate or three components, they are not able to use knowledge for wealth creation or for the society is concerned. And I think we are fortunate that almost 80 years ago, people visualized that country like India, I think if you read the first preamble where it was first policy that were adopted by government of India was that solution of this country's problem will come from S&T. Very clear mission and industrial policy. So I think we are in that position where we can utilize knowledge and provide solutions. And another thing I will particularly ask international audience to look at the location of these laboratories. There is a pattern and a vision. Every geoclimatic zone, or societal, industrial, these labs were carefully, as if somebody knew what is going to happen after 80 years. Somebody had that foresight that, okay, I will need a lab in, say, in Guwahati, or I will need a lab in Bhavnagar. So I think that is an advantage for us in CSIR. It is a translational entity and it must remain translational entity, but as we do translation, we cannot completely dependent on borrowing other people's knowledge and translate it. So body like CSIR, because it's public funded, it must have some component where we create our own knowledge and translate it. So I give you two examples. A clear example where I think there is no example in the world. And I will give you two examples from CSR contribution, how it changed the lives of the people. One is leather sector. If you go back, global leather industry, the leather sector in India, because of the availability of hides and other, it was a mess when we could not handle the sort of animal stock and all that in the beginning of when we got freedom. And I think the intervention of very high quality science, very high quality, very soon we are going to organize centenary of, I think, J.R. Ramachandran, very high quality science of structural biology, right to be application of those technology for providing solutions. And beneficiaries are the poorest of poor, and particularly the less empowered gender. So I think this is percolated down to society. And I think these kind of program where you contribute to two things. One, you contribute to employability of the people. Second thing, you can contribute to educational enhancement of the people. I think these are the two important interventions we can do. So I think this is one example where if you study that model, and I think somebody should write on this and create a global blueprint that how this model has created huge employment opportunity and wealth. How much, if you really do the number on the wealth creation, it will be, I mean, enormous. Second is pharma industry. India has the most affordable medicine in the world today. And in the very beginning, the investment in early R&D in CSIR, 4-5 labs, and then industry persuasion. It was a long journey, but today, if you go to our neighbor, the medicine are 100 times more costly. A paracetamol will cost 100 rupees, where it will cost 1 rupees. In most advanced country of the world, people, you must be reading the news that people are dying because they can't afford insulin injections, because they don't have insurance, they don't have money to buy those injections. And if you give me an example of one person not having access to insulin if he or she needs it, and I think this is where I think the lesson lies, that how do we, one hand, create capacity for industry by creating new knowledge, new technology, and the other hand, we create solutions to the disease situations of our own country. I'll give you a classic example of contribution of Dr. C. Gopalan in 1960s. Millions of children in this country used to die because of the diarrhea and other diseases, not because of diarrhea, because of loss of fluid from the body. And that is where he discovered this ORS solution, which I think we take it for granted today. You buy from the market and use it, but sometimes go back to history. I think this is a phenomenal intervention and saving millions of lives. So I think these are the examples through which, and I think CSR must continue to engage with the local community. I will make last point here that I think we need to change our model slightly differently. Rather, in some areas, we look for national solutions, but some area we deliberately look for regional solutions. Area is specific solution. If you have a technology or you have a solution which works very well in Tamil Nadu, may not work very well in Assam. And I think we have to take people cultural sensitivity, their knowledge, their traditional knowledge, particularly in nutrition, rather than trying to give everybody vitamin B12 or vitamin D or this, this kind of solution. There are multiple food habits, multiple cultural habits in this country. I think that we have yet to really, before it disappears, before in homogenization of everything, it disappears. So I think we need to do serious epidemiologically, serious genomic studies, which partly we are doing, like cancer genome we are doing. So I think the connection with the society will have to slightly refocus on the localized people, so that somehow we make people confident that you don't have to go to a city and live a very difficult life, which you can much better dignified life, you can live wherever you are. And I think that is the next level challenge for sustainable. And I think that's a message of sustainable development. Why people are just crossing the seas and dying in hundreds every day. Yesterday, why this is happening? Because of non-prioritized. And I think, again, I will emphasize here that both these areas which I mentioned here, we need another shift, is that we have to look for more biological solutions, because biology is providing some leather also and healthcare also. So we need to look for more biology integration with technology development that we are doing in chemical synthesis, API synthesis, carbon neutral processes, and all these solutions. And I think some of the effort which are happening in NCL and IICT are example of those things to come in future. So I think we are at a very, very important advantage position as a CSIR. I think when I analyze this, I think it's just sheer brilliance of the people who conceived this. It's up to us whether we are able to realize or appreciate it or not. That's our problem. Thank you.
Thank you, sir. Let me move on to Dr. Basu. You led a session where we spoke about materials and we spoke about infrastructure. Both of these things are global requirements. Now, how do you think that we can take some of the critical aspects across the world and expand the Indian science that we did very well into an international platform? Taking just a few examples out of this. Sir, you're muted.
Okay, I will start with this first thing, that India is the third largest user of materials. So we are after China and USA, we are the third largest user of material. And if I have to give you a number, if you, among all the materials which comes the infrastructure, I'm talking about the e-waste material, China produces about 10 billion tons of e-waste per annum. US produces 7 billion tons of e-waste per annum, and we produce 4 billion tons of e-waste per annum. At this rate, if it's increasing, we will definitely overtake US and we'll be at par with China by 2050. We will take US maybe by 2035 or so. So that is e-waste, but I'm talking about in general materials. So with a huge population of 1.4 billion, you require material in all aspects of human development, use, infrastructure that you require. So that is why we are blessed one way that we have a huge requirement, and at the same time we do have resources within India. Whether you are talking about mineral resources, from there you make steel or you make cement, we do have resources. Just to give an example. Now, even some of the critical minerals that required in your devices or atomic minerals, which already talked about, is also, you have a huge deposits in India. And Indian industry is also working in other countries or other continent where the resources are available, and they're either working for that country or they're acquiring resources and they're developing business to give it to the whole world. Now, with this model that we have, we of course we work for, first thing that we are looking at is we contribute the development, the material development for India, that basic needs that we require. With railway infrastructure, we are excellent having railway infrastructure, or the road infrastructure, which is being in last 15 years, 10 years, a lot more so in last 5 years, it's been tremendously improved. And the infrastructure related to houses or buildings or in hospitals or schools are also being developed in a very fast scale. Now, these infrastructure that we developed and developing could be a big boon to us, that we can take such technologies. And we are doing, India brings up technology its own way, and which is cheap and reliable. That's how we can contribute a lot to the countries who require, let's say in African countries or South American countries or Central Asia and Asia as well. The subcontinent and East Asia and Southeast Asia. So we can contribute in a large way. We can give our technology, which will be sustainable, which will be cheaper, yet functional, and of course, the resources will be available from their country or from our country, and so on and so forth. So if you take an example of the critical minerals, we are few years back, this was monopoly of few countries or one country specifically, but today there's a big thrust from the government, and all the labs within CSIR, outside CSIR, is already geared up and already working and worked out that how the critical minerals, let's say the rare earth, which is specifically goes into your many devices, whether it is required for automobile or electronic devices or e-mobility for your motors, this rare earth element, or in battery. Now India do have resources, and they acquired resources outside, and we also have a technology now, as mentioned, shown by Dr. Chaturaj, that we do have a technology to recycle our own waste. Since we are right now third and going to be second most user of material, the crux of the matter is that we need to recycle all this waste. We will call it urban mining, and then get back all of them as it is, and then use them. And we do not export much of it, and we should have a homegrown industry to use it, and which is what we are looking at it, and definitely not importing anything from outside, the critical minerals. So that's what we are looking at, and we want really open business and free business with any other country who requires such material from us, and we are working towards it. we do have a mission here on silicon material, which CSIR has taken up, that how we can make 100% pure silicon or 3.9 or 4.9 silicon, which go to in the semiconductor industry or the solar cells. We do have a mission in CSIR, and I'm sure we will be quite successful to make such a huge quantity. And we do have abundant silica resources within India. So these are some of the things that I wanted to highlight.
Sure. Thank you, Dr. Basu. So automatically you also answered one of those questions which came in the chat box, that we do have recycling capabilities and research on recycling. So automatically, when required, the lithium-ion battery recycling also would come up from our staples. So I take your words and put an answer to that question which came up in the chat box. So let me go to Dr. Rama, because that was one name that figured in all the slides. So let me ask Dr. Rama, how do you take the CSIR to the international platform? What are you doing to take the CSIR to the international platforms? Dr. Rama. Ma'am, Dr. Rama, you're muted. You're muted.
Thank you so much, sir. So for taking CSIR internationally, we are having this outreach program, for example. So we have been organizing many such outreach programs, and I'm really happy to mention that this particular program has been viewed by over 3,000 people from across the globe. So similarly, we have been having outreach exercises for reaching out to all stakeholders with our technology partnership proposals. This is one. In terms of national mission programs, Dr. Tiwari has already mentioned that these programs, for example, are not only relevant for India, but also relevant for the entire global society. And what for this we are doing is, sir, we are connecting with the foreign missions in India and also our embassies abroad, and with a request to connect us with the corresponding partners, the most potential partners for us, which could be R&D institutes, academia, industry, startups, and the government. So for example, the COVID solutions, sir, we had been discussing COVID. So when there was a shortage of oxygen generators, for example, so we were approaching through the MEA. Sri Lanka had a problem. So we were trying to connect with all stakeholders so that we can take our products trans-borders. And this is the mandate of the International S&T Affairs Directorate located at the CSIR headquarters. Yeah.
So Dr. Rama, just to add here, you also have been having some portals to attract the diaspora.
Yes. Yes, yes.
So can you please just highlight how you are doing that so that Indian diaspora abroad can also connect with you?
Yes, sir. So in 2020, we had already started working towards connecting the diaspora initially with the CSIR. But when a strong directive came from none other than the Prime Minister of India, who is also the president of CSIR Society, so the directive came that we have to develop a digital platform for connecting with the diaspora with the basic aim to address the challenges of the society. So what we did, sir, we took up a project, we took up this challenge, and we connected with many diaspora parallelly, developed a database, and also developed a portal so that we can develop this database, register the diaspora, and provide them opportunity to connect with not only CSI, but also all the scientific agencies in India. For this, we have a Prabhas portal and a Prabhas portal working group, which comprises the senior officials from all the major central scientific organizations, sir, which includes, of course, CSIR, Department of Science and Technology, Department of Space, Department of Atomic Energy, Department of Biotechnology, and there are many others which I may not be remembering, Indian Council of Medical Research and Indian Council of Agricultural Research. And in addition to having this working group, we are also partnering with other agencies, sir. For example, the NCERT, which is organizing many programs for the school children through their own PM eVidya channels. So diaspora, together with the CSR institutions, we are organizing those programs. Also, we have been connecting scientists, CSIR scientists primarily, which happens through us, for the scientific interactions, topical interactions. And MEA is the overall partner in this entire effort, sir. And I'm really happy to mention here in this forum that this particular portal called Prabhas, Pravasi Bharatiya Academic and Scientific Support, can be seen, can be accessed from all missions of India across the globe. You will, as soon as you open the website, you see the logo of Prabhas, and you can get connected to that. It now has over 6,000 database of 6,000 diaspora, and it is accessible to both India-based scientists as well as diaspora, sir, and provides opportunity in for connecting in 20 identified sectors.
Thank you, Dr. Ma. I think I'm running short of time, so let me take it to Mr. Declan. Mr. Declan, you have been giving us this opportunity to connect CSIR with the countries. My question to you is, have your expectations been met from the Science Summit and also from CSIR? Mr. Declan. Have we lost connect with him? I do see him in this. Mr. Declan? Okay, I think we are not able to get him on. So let me kind of wind up this panel discussions here with the fact that CSIR as a body can find solutions, not just for the Indian systems, but if at all any country, any industry, or any academic bodies or anyone requires our support in taking science and technology to your country, we are available. And you can please connect with us. So with this, may I now request Mr. Mohit to take the last word, and possibly we can close the session. Dr. Mohit.
Thank you, sir. Thank you, sir. On behalf of the Council of Scientific and Industrial Research, I thank the participants of our science session, CSIR India, an innovation hub for global sustainable development. This two-day event comprising 5 topical sessions and a panel discussion has briefly introduced our participants with CSIR, as also some of its S&T interventions and solutions contributing to UN Sustainable Development Goals, specifically in the areas of food and nutrition, botanical innovations, water and life below water, affordable healthcare, sustainability focused on energy, environment, cities, and communities, and also industry and infrastructure with a focus on materials for global society. I'm happy to share that the day 1 session was attended, as ma'am indicated, by over 3,000 sessions, and we expect the same viewership for today's session as well, over different platforms. We are confident that this informative and interactive event has been useful for the global scientific community, startups, industry, academia, policymakers, global think tanks, and other stakeholders working towards global sustainable development. We welcome collaborations in the areas discussed in these sessions, as also technology areas of CSIR. I take this opportunity to express our gratitude to the Science Summit at United Nations General Assembly 77 2022 Organizing Committee, especially to Mr. Declan Kiran and his team for giving us this valuable opportunity. I would like to put on record our sincere thanks to our Director General, the Organizing Committee, moderators, all our speakers and panel experts for their efforts, talks, thoughts, and time towards execution of the event. I once again thank all the participants of the session, wishing you all a very good day ahead. Namaskar. Thank you.
Thank you.
Thank you very much.
We now declare the session closed.
Thank you.
The recording has stopped.